Hi guys, today our goal is to identify organic functional groups and learn what functional groups are. Functional groups are a group of atoms within molecules they're usually a type of bonding pattern that I see with organic compounds. And these bonding patterns tell me about the reactivity of the molecule that they're in, and it also tells me about their physical properties. So I can make some predictions by looking at molecules based on what kinds of groups I see bonded, what kind of elements are bonded to each other to form these functional groups. So these are each examples of so-called functional groups. And using what we just learned about skeletal structures, you now know that there are carbons in here. So just for example, right here, okay, so don't forget what we just learned is that we've got carbon and hydrogen there, carbon. And when we talk about functional groups, sometimes it's not the whole molecule. There could be a part of this molecule that it's attached to. So when you see these lines in the context of functional groups, it could mean that some kind of other thing is bonded here. So just keep that in mind, that this could be hanging off as a portion of a larger molecule. Same thing here. We might have things attached here and here and here, but what's important is the pattern of a C double bond O and an H for this one, and then here C double bond O and N attached to two different things. So those are sort of the bonding patterns that we're looking at. I'll go ahead and keep highlighting. This is a type of bonding pattern. This is the bonding pattern. This is the bonding pattern. Okay, so those are the key parts that I'm looking at to tell what these are. And this looks sort of funny right here. Do you guys know what that is? That's got how many carbons? It's got 2 carbons. And so it can be bonded to other things, or it could be bonded to hydrogen. So I'll just do a little squiggle line, just means it's attached to something else. Sometimes instead of squiggle lines, chemists use an R. So R, sorry, let me do it here. Instead of a squiggle line to mean it's attached to something further, I can use this R. R stands for radical. We're not going to learn really about radicals, but they are these groups that you can link up. So there's that. This is a double bond functional group here. So carbon double bond functional group. And then here, this is a very important functional group as well. Well, all these functional groups have names. You'll learn about those right here. This is not anything you have to memorize for intro chem. If you were to take a majors level organic chemistry, you probably would most likely have to memorize these. But for you in introductory chemistry, you'll be using this chart. You'll be provided with this chart, or you can use the one in your workbook when you get questions about this on the quizzes. So alkanes are just C single bond functional groups. We don't really name them very much. Alkenes, though, if you see a CC double bond and then things attached to that double bond, that's called an alkene. Here's our alkyne. This is called an aromatic ring, and there are 3 different forms you could draw it in. Alcohols have an OH group, thiols an SH group, ethers are if you see this bonding pattern. So anyway, it's just a long list of them. The reason why they're helpful is because when you take biology and you'll learn about all different kinds of molecules like proteins and carbohydrates, you'll see a lot of these bonding patterns, and it's important for you to know some of that chemistry behind those molecules. These over here on the right are just examples of types of molecules which incorporate these functional groups. So let's take a look right here. If you saw a molecule like this, you'd be asked, what is the functional group in this molecule? You could say, oh, I see this double bond C. That is an alkene. Okay, and you can use the chart to do that. Here's another molecule. What's the functional group here? It's right here. So basically what you can do is sort of ignore this single bonds, just look straight for double bonds, triple bonds, and then anything that's not carbon, like this oxygen here. Ooh, that looks like a nice functional group. That is this functional group, which is called an alcohol. Sometimes that's called a hydroxyl group, so that's used a lot. So I'm going to just add that here, hydroxyl. And same thing with amino. So if you go down here, you see like amino acid. So amine group has a nitrogen with things bonded to it. So I'm going to put that term here because you see those terms a lot. Some of these functional groups look similar. Like you can sort of group these together because they have the C double bond O that's in common. And this C double bond O has its own name. So any molecule with the C double bond O might be referred to as a carbonyl containing group. So the C double bond O is called a carbonyl. Carbonyl. YL just means attached to. So it's carbonyl group. So you might want to look at a molecule and just ask yourself, does it have a carbonyl group or not? Because that will help you narrow it down. So for example, let's say I just looked at this molecule and was asked, what functional group is in there? So what I'm going to do is look for things that are not just carbon-hydrogen single bonds. So if I look, that's all just boring alkane stuff. I don't care about that. But look at this guy right here. So that looks different. And then I look at, oh, it's a carbonyl. It's going to be one of these guys with the carbonyl group. Okay, well, which one is it? So for that case, I have to look at what it's attached to on either side. So I'm going to include those as well. So I'm going to look at a carbonyl that's bonded to a carbon group on one side and another carbon group on the other side. They could be the same or different. So I'm going to look here. This is a carbon but with a hydrogen. This is a carbon with a carbon. Oh, boom. That is a ketone. Okay, so this is a molecule with a ketone in it right here. Or this molecule is a ketone. Some molecules have multiple functional groups in them, so it could be, who knows, a combination of those. But another important thing here is if you look at this molecule, again, it's got a carbonyl, so it's going to be one of these over here on my left. But it's got a carbon on one side and an OH group on the other. So that's going to help me identify which of these carbonyl groups it is. So carbon on one side, oxygen, hydrogen on the other. So if I look over here, oh, here's my oxygen, hydrogen. But wait a minute, oxygen, hydrogen was over here. So it turns out that if there's a carbonyl group, it has a totally different chemistry than if it just had the OH group. So you really have to keep your eyes peeled. If you only saw this and no C double bond O, then it would be called an alcohol. But because it has both of these together in this arrangement, it's called a carboxylic acid. All right, well, we're going to practice identifying those using that chart. So I'm not going to flip back and forth, but you can use your chart so you can follow along. What I'm going to do is to show you these molecules that are relevant in our lives, like aspirin, cinnamaldehyde, cortisone, and these are all organic molecules. They have carbon and hydrogen and other elements in them. So let's take a look at aspirin. So just a review, this is their skeletal structure here. So there's this carbon here, and a carbon, carbon, carbon. So this is just sort of a review. You know, how many carbons do we have? 1, 2, 6, 7, 8, 9. Okay, so C9. And then draw in the hydrogens. 1, 2, 3, 4, 5, 6, 7. Oh, and 8 because of this hydrogen on the OH group. Don't forget that one. And then we've got 1, 2, 3, 4 oxygens. So, and then you can Wikipedia this too. You can just Google search aspirin and it'll come up with the chemical formula if you're not sure what it is. It's a good way to check your answer. I know Wikipedia is not good for everything, but for chemical stuff, it's not a bad starting point. This is really basic info that is generally not, is going to be pretty reliable on most sites. Okay, so functional groups. So for functional groups, it might help to just erase some of this and just look at the other stuff. What I'm going to do is walk you through highlighting, you know, where do I even start with this thing? So first of all, like I said, I would recommend you look at double bonds, triple bonds. So see these double bonds in here? So this whole thing is actually a functional group. So see if you can find it on your chart. This is called aromatic or benzene ring. Okay, so this is, I'm going to label it aromatic. And so this, I'm basically just doing a matching, you know, matching the structural features to that chart that we just looked at. Okay, another functional group would be, I see a C double bond O, here's my carbonyl group. What is it attached to? Okay, so it's got carbon in the form of this aromatic group on one side, and it's got an OH group on the other. So remember looking at that, where we had a carbonyl and an OH group? So that's called carboxylic acid. Okay, so you could also call it a carboxyl group, or you can call it a carboxylic acid. Carboxyl is the name of the group by itself. Carboxylic acid is the name of the class of molecules which contain it. So either one is fine, sort of a specific thing that you may not have to know. And then this is the other thing that's left. I know it's a functional group because it has a carbonyl group. I see an O on one side and a C on the other. Is this different from this? You see that this has an H on it and this has a carbon on it. So I'm actually going to highlight that too. So it's very important to have each specific part that's going to tell you. So it looks very similar, but it's not the same because there's a carbon here and here there's a hydrogen. So I'm going to go up to my chart and I'm going to see if I can find it. It's got a C double bond O. It's got an oxygen attached, but not a hydrogen. It's got oxygen and a carbon. So this one's called an ester. So let's find that ester right here. So we're going to name it Esther. And so now if you ever meet anyone named Esther, you can say, hey, you're a functional group. Okay. All right, so you can do the same thing with the rest of these molecules. Try to identify what is the unique functional group besides carbon and hydrogen. What else do we have going on? Double bonds, triple bonds. See, look, there's that aromatic group again. This is a functional group, find out what it's called. This is a functional group, find out what it's called. And I want you to circle it or highlight it and then label it with what functional group it is, just like we did over here.